Everyone thinks Nvidia owns AI because of GPUs. That's wrong. Nvidia owns AI because once you build on CUDA, leaving becomes painful. That pain is the moat. But right now, that pain is starting to shrink, not because Nvidia got weaker, but because Google and Meta are testing a way around it. If they succeed, Nvidia doesn't disappear. Something more important happens. Customers get options. And in infrastructure wars, options change everything. To understand why that matters, you have to understand what Nvidia actually controls. And it's not what most people think. For nearly 2 decades, Nvidia has owned AI computing, and that dominance wasn't built on having the fastest hardware. It was built on something far more powerful, the impossibility of leaving. Reuters published a report that changes everything. Google is building a system specifically designed to target the one thing that's kept Nvidia untouchable. This isn't about better chips. This is about unlocking the door that's kept the entire AI industry trapped inside Nvidia's ecosystem. And if it works, the next 12 months could quietly rewrite the rules of who controls artificial intelligence infrastructure. Stay with me, because what I'm about to show you is the most important shift in AI that nobody's talking about. Let me show you how Nvidia actually became untouchable, because most people completely misunderstand this. When you hear Nvidia dominates AI, you probably picture the most powerful chips on the planet, cutting-edge GPUs, unmatched performance. And yes, Nvidia makes exceptional hardware. But here's what separates a successful company from a $4 trillion empire. Nvidia didn't win on hardware. They won on lock-in. Think about it like this. Imagine you're an AI developer at OpenAI, Meta, or any major tech company. You're building the next generation of language models. You write your code in PyTorch, the most popular AI framework in the world, used by virtually every major AI lab on Earth. That code doesn't just magically run on chips. It needs a translation layer, something that converts your high-level instructions into optimized machine execution. For Nvidia, that layer is called CUDA, and CUDA isn't just software. It's nearly 20 years of engineering refinement, low-level math libraries, memory optimization, distributed training protocols. Every possible performance gain squeezed out through relentless optimization. Nvidia's engineers spent 2 decades making sure that PyTorch, the framework everyone uses, runs faster, more efficiently, and more reliably on Nvidia hardware than anywhere else. That created something more powerful than technical superiority. It created institutional lock-in. Here's the part that matters. Most monopolies break when a better product appears. Software monopolies weaken when switching stops being irrational. And switching away from Nvidia isn't just expensive, it's architecturally painful. You don't just buy different chips. You rewrite low-level kernels. You replace CUDA-specific operations. You retrain engineers who've spent years mastering Nvidia's tools. You revalidate production models. In large organizations, that process takes months and costs millions of dollars. So even when alternatives exist, even when they're cheaper, even when supply is better, companies stay put. That's not a hardware moat. That's an ecosystem fortress, and it's worth more than any chip design could ever be. So what happens when someone figures out how to lower that switching cost? Not eliminate it, just make it manageable. That's exactly what's happening right now. Reuters broke a story that should have sent shockwaves through the entire AI industry. According to sources familiar with the matter, Google is working on an initiative called Torch TPU, a project specifically designed to make PyTorch run seamlessly on Google's TPU chips instead of Nvidia's GPUs. Now, before you think just another Nvidia competitor, let me explain why this is fundamentally different. First, understand what TPUs actually are. TPUs, Tensor Processing Units, are Google's custom-designed AI accelerators. They're optimized for the massive matrix operations that power modern AI, and they're not inferior hardware. In many workloads, they deliver performance competitive with Nvidia's best offerings. Google has something else Nvidia sometimes struggles with: supply. TPU production is under Google's direct control. They can scale availability. They can manage allocation strategically. But for years, TPUs had a fatal weakness: software compatibility. Here's the problem Google faced. Internally, Google built its entire AI stack around a framework called JAX. JAX is powerful. Google's engineers love it, but almost nobody outside Google uses it. The rest of the AI world runs on PyTorch. Researchers use PyTorch. Startups use PyTorch. Enterprise AI teams use PyTorch. It's the lingua franca of artificial intelligence development. Asking companies to abandon PyTorch and adopt JAX to use TPUs was like asking them to abandon English and learn Esperanto. Technically possible, practically absurd. So despite having competitive hardware, TPUs stayed dramatically underutilized by external customers. Everyone kept buying Nvidia. According to Reuters sources, Torch TPU represents Google's most serious attempt yet to solve this problem, not by asking developers to change their workflows, but by making PyTorch, exactly as developers already use it, run natively on TPU hardware. Same training scripts, same debugging tools, same model architectures, zero code changes. The sources told Reuters that compared to earlier attempts at PyTorch TPU integration, Google has devoted substantially more organizational focus, engineering resources, and strategic importance to this project. Why? Because customers have been explicitly telling Google that software compatibility is the primary barrier preventing TPU adoption. Here's the line that matters. This is not about making TPUs universally superior to GPUs. This is about making PyTorch less exclusive to CUDA. And there's another detail buried in the Reuters report that amplifies the threat. Google is considering open sourcing parts of Torch TPU. That's not a minor footnote. Open sourcing accelerates adoption dramatically. It lets the entire AI community test, refine, and improve the software. It eliminates vendor lock-in fears. It signals long-term commitment beyond Google's immediate business interests. But if this were just Google trying to sell more of their own hardware, it would be interesting. What makes this a genuine threat to Nvidia is who else is involved in this effort. Here's where this story transforms from tech company builds software to existential challenge to Nvidia's foundation. According to Reuters sources, Google is working closely with Meta on Torch TPU development. Why does that matter? Because Meta didn't just adopt PyTorch. Meta created PyTorch. Meta maintains PyTorch. Meta is the steward of PyTorch's development direction. And here's the critical detail that changes everything. Nvidia doesn't control PyTorch. They never have. They never will. PyTorch is open source, governed by the PyTorch Foundation, where Meta holds enormous influence. That means Nvidia cannot block changes that make PyTorch more hardware agnostic. They can't slow down development. They can't veto features that threaten their lock-in. They're watching from the outside while the creators of the framework they depend on collaborate with their biggest competitor. Now, why would Meta help Google with this? The answer is strategic leverage. According to the Reuters report, Meta has been discussing arrangements to access more TPUs from Google. This was first reported by The Information. Let me explain the economics here. Running AI at Meta's scale costs billions of dollars. Their Llama models alone require staggering amounts of compute. Right now, Meta is heavily dependent on Nvidia hardware. When you have only one viable supplier, you have no negotiating power. When Nvidia raises prices, you pay. When there's a supply shortage, you wait. When you want better contract terms, you have nothing to bargain with. According to Reuters sources, Meta has a strategic interest in making it easier to run workloads on TPUs, specifically to lower inference costs and diversify AI infrastructure away from Nvidia's GPUs to gain negotiating power. This isn't about Meta abandoning Nvidia. It's about Meta ensuring Nvidia isn't their only option. And the collaboration makes perfect sense for both companies. Meta gets infrastructure diversification and cost leverage. Google gets Meta's deep expertise in PyTorch to make TPUs genuinely developer-friendly. Reuters reports that early TPU offerings for Meta were structured as Google Managed Services. Google's chips running Google's software with Google providing operational support. Now, the collaboration is deepening to make the software stack itself more flexible. There's another detail in the Reuters report that shows how serious Google is about this shift. This year, Google began selling TPUs directly into customers' data centers rather than limiting them to Google Cloud. That's a fundamental strategic change. TPUs are no longer just a cloud service. They're being positioned as infrastructure you can own and operate, the exact same territory Nvidia GPUs occupy. According to Reuters, Amin Vadat, a Google veteran, was named head of AI infrastructure this month, reporting directly to CEO Sundar Pichai. That organizational move signals executive-level priority. So if Google has hardware, Meta is supporting software development, and supply is available, does that mean Nvidia's dominance is over? Not even close. But the nature of competition is about to fundamentally change. Let's talk about timing, because this isn't happening in a vacuum. According to the Reuters report, TPU sales have become a crucial growth engine for Google Cloud as the company seeks to prove to investors that its AI investments are generating returns. That context matters. Google isn't just building tools for fun. They're under pressure to demonstrate that their massive AI infrastructure spending translates into revenue. And the spending is massive. While the Reuters article doesn't specify Google's exact capital expenditures, separate reporting indicates Google's AI infrastructure investments are reaching unprecedented scale. When you're investing at that level, utilization becomes critical. Having world-class hardware sitting underutilized because of software friction is unacceptable from a business perspective. That's why Torch TPU isn't just an engineering project. It's a strategic imperative. Here's the insight that matters. This doesn't destroy Nvidia's moat. It changes who controls the drawbridge. Nvidia still has advantages. CUDA remains years ahead in maturity. Their developer tools are more comprehensive. Their ecosystem is more established. Their hardware continues to set performance benchmarks in many workloads. But according to Reuters reporting, if Torch TPU succeeds in significantly reducing switching costs, enterprise customers gain something they haven't had in years: options. And in infrastructure markets, having options changes everything: pricing negotiations, supply allocations, long-term strategic planning. Nvidia's dominance shifts from structural inevitability to something that must be defended through continuous innovation. The Reuters article notes that Nvidia's dominance has been reinforced not only by hardware but by the CUDA software ecosystem, which is deeply embedded in PyTorch and has become the default method for training and running large AI models. Wall Street analysts, according to the report, regard CUDA as Nvidia's strongest shield against competitors, not the chips. The software lock-in Torch TPU targets that shield directly. Now let's be realistic about what happens next, because credibility matters more than hype, and timelines matter more than headlines. Here's what the Reuters report doesn't say, but needs to be understood. This will take time. Making PyTorch run efficiently on non-CUDA hardware is extraordinarily difficult. Performance parity isn't guaranteed on day one. Google will likely need 12 to 18 months minimum to refine Torch TPU, prove reliability at production scale, and harden it for enterprise workloads. CUDA's two-decade head start doesn't disappear overnight. But infrastructure shifts don't require overnight revolutions. They require the second option becoming good enough. Not better, not revolutionary, just good enough that switching stops being irrational. According to the Reuters sources, enterprise customers have explicitly told Google that TPUs are harder to adopt because they historically required switching to JAX rather than continuing to use PyTorch. Torch TPU aims to eliminate that barrier entirely. If it succeeds, companies can evaluate TPUs on actual merit, performance, cost, supply availability, rather than dismissing them due to software incompatibility. Nvidia's response options are limited. They can't acquire Google or Meta. They can't control PyTorch's evolution. They can't prevent open-source development. Their primary defense is advancing CUDA faster than competitors can replicate its capabilities. That keeps them competitive, but it transforms CUDA from an unassailable fortress into a position requiring constant reinforcement. And for investors, that distinction matters enormously. Here's the bottom line from the Reuters report and what it means. For the first time in nearly 2 decades, Nvidia's software lock-in, the foundation of their dominance, is facing a credible challenge from the creators of PyTorch itself, working with a competitor that has supply, hardware capability, and strategic motivation. This isn't about Nvidia disappearing. According to their own cloud spokesperson quoted in Reuters, Google is seeing massive accelerating demand for both TPU and GPU infrastructure. This is a growth market. Multiple winners can exist. But the question isn't whether Nvidia remains a leader. The question is whether their dominance stays structural or becomes earned through continuous innovation. Does CUDA remain untouchable, or does developer choice quietly reshape the AI infrastructure landscape? The Reuters report suggests Google and Meta are betting on the latter. The next 12 to 18 months will show whether they're right. If you want to stay ahead of these infrastructure battles as they unfold, subscribe now. Because the most important shifts in technology don't happen in product launches. They happen in the invisible software layers where lock-in either holds or breaks. And this is where it's being tested.